Overview of electric vehicle technologies. In this, we'll see first the motor drive technologies. If we see the technologies which are mainly important is the motor drive technologies, energy source technologies, and battery charging technologies. First, the motor drive technology is the propulsion technology, energy source technology, which are the sources used for electric vehicles, and battery charging technologies where various battery charging types and battery charging infrastructure. The motor drive technology, this is the core technology for electrical vehicles that convert the onboard electrical energy to the desired mechanical energy. The requirements of electrical drives or machines for electrical vehicle are the drive should have, the machine should have high torque density and high power density so that it can deliver required torque and required power to the vehicle, and it will have a smaller size. Also, the machine should have wide speed range covering low speed creeping and high speed cruising speeds. So it can change its speed from minimum to the high speed. The drive should have higher efficiency or wide torque and speed range. The electrical machine should have higher efficiency or wide torque and speed ranges. The machine should have wide constant power operating capability. Also, it should have high torque capability for like launch and hill climbing. So depending on the road conditions, it should provide the required torque. So it should have high torque capability. High intermittent overload capability for overtaking. So for overtaking, it will suddenly have the required torque, and also it should sustain the overload and overtake the vehicle. So this is one of the intermittent feature. So it should possess this high intermittent overload capability. Next, it should have high reliability and robustness for vehicular environment. It should be a reliable one. The drive should or the machine should be reliable. Low acoustic noise. In electrical vehicle, the noise of the machines or the motor is important thing. So it should have low noise. And obviously the cost should be a reasonable cost. It should not be heavily cost. When the electric machine needs to work with engine for various hybrid electric vehicles, they also require some additional requirements. They have high efficiency, power generation over wide speed range, good voltage regulation over wide speed generation, capable of being integrated with the engine. So whenever it is working with hybrid electrical vehicle, the motor is working with the IC engine propulsion also. So it should provide these capabilities. If you see the broad classification, we can get this classification, general classification chart. The electric vehicle machines can be classified as commutator based motors or machines and commutator-less based. In commutator based machines, electrical machines, it will be a DC type where a commutator is the rotating part and it collects the current, and it will work also as a rectifier inverter, mechanical rectifier and inverter depending on the motoring and generating mode. So DC can be also wound field and permanent magnet field. So wound field, the winding is wound, and winding is wound to produce the field. In permanent magnet, the field or flux is produced by the permanent magnets. A wound field type can be further classified as a series wound, shunt wound motor, or separately excited motor, where the excitation or field is given a separate supply. In the commutatorless, there is a big classification. It can be induction motor or induction machines, synchronous motor, doubly silent motor, or vernier motor. In induction motor also there are two types, wound rotor or cage rotor. If based on the rotor, induction motor is classified. Now in wound rotor, the rotor has again the winding on it, and in the cage rotor, the rotor is having a solid conductor bars, and it is a robust and simple construction. In synchronous machine, it will have wound rotor, it will have permanent magnet rotor or reluctance rotor type synchronous motor. Now, if you see the type here, it will have permanent magnet rotor will have permanent magnet PLAC brushless AC motor and permanent magnet brushless DC motor. So these are the popular type of drives or motors used for vehicle applications. Now in doubly salient, so saliency is nothing but the projections. So the poles are having the projections, so it is called as a saliency. So on rotor also there is some saliency, there are poles. On stator also there are saliency and poles. So depending on, it is called as a SR, that is switch reluctance, and stator permanent magnet. In stator permanent magnet will have further TSPM, doubly salient permanent magnet, then FRPM, flux reversal permanent magnet, and FSPM, flux switching permanent magnet machines. Another type is the flux controllable type stator permanent magnet motors. So it can be further classified as flux controllable DSPM, doubly salient permanent magnet machine, or it is second type is flux controllable FRPM. It is nothing but flux reversal permanent magnet, and last one is the flux controllable FSPM, flux switching permanent magnet, is nothing but the FSPM machines. So how the winding and magnets are placed inside the motor will decide this stator permanent magnet types. One more type which is recently popular is the vernier type of motors, that is vernier permanent magnet and vernier reluctance. These are the two types. If we see the motors which are more suitable for this are the permanent magnet field, series type, shunt DC motor, separately excited DC motor, which were earlier used for electric vehicle applications. Then the next type is the cage rotor type of induction motor used for electric vehicle applications. So the motors which are shown in a bold letters, bold font are mostly used. Then permanent magnet brushless AC motor, permanent magnet brushless DC, these are popular. And also in doubly silent switch reluctance motor are also popular type of electric vehicle machines. If you see the doubly silent machines, the key feature is the presence of silent poles on both stator and rotor. The SR machine is kind of doubly silent. Switch reluctance machine is kind of doubly silent machine having the simple structure. Incorporating permanent magnets in the stator of doubly silent machines, the new class of permanent magnet brushless machine is resulted in the stator permanent magnet. So where the magnets are placed on stator or rotor will decide this permanent magnet machines. Since the rotor has neither permanent magnets nor winding, this class of machines is mechanically simple and robust, hence very suitable for operations. According to the location of permanent magnets, this can be splitted as a doubly silent permanent magnet, flux reversal permanent magnet, flux switching permanent magnet as seen in the classification. I will briefly discuss recently in picture, which was earlier developed, used one of it can be one of them. The vernier machine uses vernier effect to amplify the output torque while stepping down the speed, leading to a class of dedicated to low speed, high torque drive application. So there are two main classes of vernier machines: vernier permanent magnet, that is VPM, and vernier reluctance. So there are different types of vernier permanent magnet machines depending on the location of permanent magnets. The rotor permanent magnet type with all permanent magnets mounted on the rotor, the stator permanent magnet type with all permanent magnets mounted on the stator, and all PM type with permanent magnets mounted on both the rotor and stator. Hybrid electric vehicle machines. Now, apart from this electric vehicle motor drives for pure electric propulsion, the technological development of EV machines has extended to hybrid propulsion systems. There are two main machines for hybrid propulsion: the integrated starter generator, that is ISG system for micro and mild hybrids, and EVT, electrical variable transmission system for the integrated starter generator, that is ISC system, needs to offer not only conventional features of engine cracking and electricity generation, but also the hybrid features of the idle start off, regenerative braking, and power assistance is also required. Therefore, corresponding machine design, analysis, and control are very demanding. In the AVT, functions to offer electrically controllable power transfer from the engine to the wheels with continuously variable transmission, hence providing all hybrid features including the electric launch, idle stop start, regenerative braking, and power assistance, as well as achieving the highest fuel economy. There are three main types of EVT systems: planetary geared electric vehicle transmission called as a PGEVT, exclusively used full hybrid. For full hybrid example, Toyota Prius. However, this PGEVT system inherits the fundamental drawbacks of planetary gearing, namely the transmission loss, gear noise, and need for regular lubrication. Next is the double rotor vehicle transmission, DREVT. It is a gearless DREVT system. This double rotor Electric vehicle transmission DREVT system needs to employ slip rings and carbon brushes to extract the energy from the inner rotor, which suffers from the reliability concern and need of regular maintenance. Next is the magnetic geared electric vehicle transmission MGEVT. Replacing the planetary gearing with magnetic gearing, the resulting MGEVT system has a distinct advantage of magnetic gearing, high transmission efficiency, silent operation, and no maintenance while avoiding use of slip ring and carbon brushes. This is the classification of hybrid electric vehicles for micro, mild, and full. For micro, it is ISG, while also can be used ISG. For full, PGEVT, DREVT, and MGEVT as explained earlier.